Good morning. Once again, I welcome everyone for today's session. In computer networks, today we are going to discuss about flow control techniques. This is Geeta, Assistant Professor Senior Grade, Department of CSC from KPR Institute of Engineering and Technology, Coimbatore. Flow control in data link layer is very important task. So why flow control is needed in a data link layer? So what is flow control? So flow control is a kind of mechanism. So this mechanism is mainly needed for controlling the flow between any two devices or more than two devices. Why we need to control and manage the flow between devices? To prevent the data loss, suppose if the sender is sending the data but the receiver cannot capable to receive the data, then there may be possibility for data loss. So to ensure the reliable communication without any data loss, there should be a flow control mechanism needed. So this will be taken care by the data link layer of the OSI model. As I already told, flow control is a design issue at data link layer. So the data link layer is responsible for many other tasks like error control, flow control, and access control. Flow control is an important one. It is a technique and it is generally observe the proper flow of data from the sender to the receiver. Flow control in data link layer simply restricts and coordinate a number of frames or amount a data center sent just before it waits for an acknowledgement from the receiver side. See, say for example, if I keep on teaching something for an entire hour, then half of you may not understand what I am telling, right? So just I want to ensure then and there whether you people can capable to receive what I am trying to convey. So this is very important, right? In a classroom. Similarly, when two devices are trying to transmit the data between them, then the device should be capable to process the data which is received by other device. So this is known as flow control. So center want to know whether the receiver can capable to process the data which is sent by the center. There will be a thing called buffer in both the sides, center side and receiver side. The receiver is going to store the data in buffer before processing it. So in case the receiver buffer is full, then there is a possibility of data loss. So this mechanism mainly mainly when the sender is transmitting the data faster, then the receiver capable to process it. So this is a kind of technique. For that we have so many techniques to control the flow at data link layer. So common approaches for flow control at data link layer is feedback based flow control technique and array based flow control technique. So these two are the main method implemented at the data link layer for flow control. Feedback based flow control technique, which is going to rely on the receiver. Receiver is going to provide a feedback to the center about its ability to handle incoming data. Based on the feedback of receiver, the center is going to decide how many how many packets can be transmitted to the receiver. So the receiver is going to explicitly inform the center about its current state, and it is going to indicate when it is ready to receive more data, or when it needs the sender to slow down. So based on the feedback of the receiver, the center is going to send the data to the number of frames will be sent by the center will be decided only based on the receiver's feedback. So the center is going to adjust its transmission rate based on the feedback received by uh, receiver. The second type of flow control technique is rate-based flow control technique. So in the rate-based flow control, which is going to focus on controlling the transmission rate of data based on the predefined parameters rather than relying on explicit feedback from the receiver. So what we discussed in the previous technique is about feedback-based flow control technique, where the receiver is going to explicitly inform the center about current state of the receiver. So based on the feedback received by the received by the receiver, the sender is going to slow down its data transmission. But in the case of rate-based flow control technique, there will be a predefined parameters. Based on the predefined parameter, the sender is going to transmit the data. So the sender determines the appropriate rate of data transmission based on the network condition and the capability of receiving device. So in a rate-based flow control, the sender typically set an initial transmission rate and monitor the network for their congestion and or performance degradation. So based on the congestion, the sender is going to transmit the data packet to the receiver. So say if the network is affected with congestion, then the sender is going to slow down the number of packets transmission to the receiver end. So in round-based flow control, for identifying the network congestion, there may be an algorithms used to identify the congestion of the network. So and also TCP congestion control mechanism dynamically the transmission rate will be adjusted based on the network feedback. So it may be consider some of the parameters like packet class, round trip time, and and many more parameters. Based on the factors like available bandwidth and other things, that the sender is going to transmit the number of packets to the receiver. So by considering the predefined parameters, the sender is going to fix how many number of packets can be transmitted to the receiver. So this is about rate-based flow control technique. This is the second type of flow control technique is used commonly. So here in this slide we are going to discuss about two different type of flow control in data link layer. So one is stop and wait flow control technique and another one is sliding window flow control technique. These two are a very famous flow control technique which is used in the data link layer. Stop and wait flow control technique is a kind of technique. It is a very simple form of flow control technique. So here in this technique, data will be broken into various multiple frames and the receiver is going to indicate its readiness to the sender that the receiver is ready to receive frame of data. When an acknowledgement received, then the sender is going to send the next frame to the receiver. So here the process is very simple. Sender is going to transmit the data to the receiver. Once the receiver is receive the data, then it is going to acknowledge to the sender that I received the packet. Once acknowledgement received by the sender, then the sender is going to transmit the second packet to the receiver. So this process will continue until the sender is going to transmit end of transmission, that is called EOT. So this is a very simple and easiest method of flow control technique. So here is the diagram for stop and wait flow control technique. As I already told, the sender is going to transmit the data, and once if the receiver receives the data and the receiver is going to transmit the acknowledgement packet to the sender, that the acknowledgement is indication that the receiver is ready for for receiving the second packet. Then after receiving the acknowledgement, the sender is going to transmit the second data to the receiver. So in this way we are going to transmit the data from a sender to receiver without any data loss. So this is the simplest technique. So in today's session what we have discussed is what is the necessity of flow control and data link layer, and what are the two different technique under flow control technique. One is rate based flow control mechanism and feedback based flow control mechanism. And two commonly used flow control technique in data link layer is stop and wait protocol and sliding window protocol. So we understand what is stop and wait protocol. In the next session we are going to discuss about what is sliding window protocol and how it is efficient when compared to the stop and wait protocol. Thank you all. Thank you for listening my session. Thank you.